Hi everyone. So let us have a look at a piece of code. So you can see I have a very simple class number which encapsulates integer x. So when we instantiate this number, x is initialized to 0. Okay. Now we have two very simple methods here, getX and setX. So get gives you the value of x and set allows you to set something inside the x. As simple as that. Moreover, these two methods are synchronized. Now we all know what is the meaning of making something synchronized. It basically means that whenever a thread invokes this method or gets inside this method, it will acquire lock on something. And what is that something? It is nothing but the instance of this number, the object of this number, which was used to make a call to get of x. Okay, so it means that when a thread has invoked get of x and has gotten inside this critical section, some other piece of code will not be able to do that. Okay. Similarly, because here also we have placed synchronized, so it basically means that when a thread is inside get of x, another thread cannot get inside set of x also. Why? Because it's the same lock which is being used to lock this as well as that. Okay, cool. So at a given point of time, if a thread is in set, other thread can neither get inside set nor get inside get. Okay, so having understood this thing, let's say I want to write a piece of code which allows me to increment the value of x by 1 unit. How will I do so? So thinking sequentially, I can simply say that let me create number and then I can call number dot get of x. The moment I do this thing, I'll be able to grab the old value of x, correct? Now all that I can do is I can do number dot set of x and here I can set old val plus 1. It all looks perfectly well and it will function correctly in the sequential world. But what if I have multiple threads that are doing this thing in order to increase the value of x by 1 unit? Will there be some trouble given the fact that the two methods that I have shown you are already synchronized? Just pause the video and think through it. Okay, so now what I'll do is I'll create a worker which is nothing but a type of runnable and it takes an number instance, okay, and then it does the same thing. Okay, now I'll take you back to the main function where my intention is to create some threads. So I'll create two threads, thread 1, and this thread 1 will have a worker of its own, and that worker will have this number that I have just created. Okay, in the exact similar manner, I'll go ahead and create another thread. I'll call it thread 2. And here also everything is same. It has its own worker, but they are sharing the same number. Okay, so basically the two threads are sharing the same x. Okay, cool. Now let me just start thread 1, t1.start, and let me also start thread 2, t2.start. Okay, so now the two threads have been launched and I'll wait for them to terminate. So I'll end with thread.join. So whenever you write thread.join, keep it in your mind that this join throws an exception called as interrupted exception. And because it throws, so it needs to be introduced to the method signature. So if you get warnings like that, hey, you're using join, you need to alter the method signature by adding this thing. Please don't get worried because this is required by the semantics of Java. Okay, cool. Now finally what we'll do is we will just go ahead and print the value of x. So for that I can say system.out.print number.get of x. Okay, so now if I want, I can run this this particular program and see what happens. So we created two threads and we launched both of them, right? And we waited for them to terminate. The initial value of x, as I showed you, was 0. So the final expected value of x should be 2 and that is what has been printed. So everything is good so far. But can it go wrong? So let's guys just think about it. So guys, if you look at the action that has been performed by a certain thread, then this is a compound action actually. Now we need to first understand what do I mean by compound action. So compound action is something which basically is composed of multiple different actions. So it is composed of action 1, action 2, and then there can be some other actions also. So I can say the process of incrementing the number by x has two actions involved. The first action is to call getX, and the second action is to call setX. Okay, now both these actions, when seen independently, are already synchronized. Okay, but if both of them are independently synchronized and if both of them are thread safe, does it also mean that this compound action as a whole will also be thread safe? The answer is no. Why? Let us try and understand. Let's say a thread T1 has just got scheduled. When it got scheduled, it read the value of x and it found out to be 0. Now, a context switch happened and thread 2 got scheduled. That thread 2 will also read the value of x to be the same thing, which is 0. So both of them will set the new value to be 0 plus 1, which is 1 only. So you will see that there are two threads which have made an attempt to add plus 1 to the previous value of x. In reality, the result is different. The result is 1, the result is not 2, which we wanted. Okay guys, so this is something which can happen because of the manner in which CPU scheduler schedules the different threads out there. But important thing to understand is that if you want your compound action to be thread safe, then in order to do that, if you make your independent actions as thread safe, then that is not going to be enough. So if you introduce thread safety for action 1, and then you also introduce the thread safety for action 2, and as a consequence of doing this thing, if you want this entire compound action to be thread safe, that is not necessarily true. Why? Because whenever you perform action 1, it can happen that by the time you have moved on to action 2, the value that you had read is now a stale value, isn't it? Because when thread 1 got scheduled, it found the value of x to be 0. And now when thread 2 got scheduled, it also found the value of x to be 0. But in reality, the thread 1 would have altered it to 1, right? Because of this step. But because thread 2 got scheduled before this alteration, so it would realize that, hey, the value is still equals to 0. So it's like basically reading the stale values. So this is what happens in case of compound action. So guys, there are so many compound actions that we have in our life also, that we observe usually in our lives. So think of a very simple example. Let's say you placed order on Amazon. Okay, now you placed an order and you specified your address to be something. Now by the time the order was about to be delivered after 15-20 days, whatever, you changed your address. So in that case, what would happen, that this scenario, if you look at this entire scenario, this was like a compound action based scenario. The first action was to read the address, and the second action was to deliver the product. So read the address happened. Now when delivery of the product was happening, in between of that, the address actually got changed. So whenever there are such scenarios in your code, they can definitely lead to thread safety issues. Okay, so if we have to take care of this thing, what to do? What would be a possible fix to this? Can you just pause the video and think through that? Okay, so the easiest fix that comes to our mind is that probably we can have another method, which can be a public method, and I'll call it increment So whenever somebody calls increment, what it does is that it increases the value of x by 1 unit, and it can easily do so by invoking getX and setX, the two methods that already exist. So what it can basically do is it can call get of x, and from here it can get the old value. Basically, I am writing the same piece of code that was previously written inside the worker, and now it can simply call set of x, and there it can pass old value plus 1. Now, do you realize the need to make this thing also synchronized? It's important, because if you don't make it synchronized, the same problem will again happen, because all that you have done is you have moved this piece of logic from here to somewhere else. Now, it's not just the movement that I was interested in. I was interested in making it atomic. Okay? You know what atomic is. The same thing, that if a compound action is made up of multiple actions, then just making those multiple actions synchronized or atomic is not going to help. You have to make that entire compound action as a whole synchronized or thread safe or atomic. Okay? Cool. Now that we have understood this idea, so we can just go ahead and make this thing synchronized and then expect this thing to work. However, what I'll do is I have still not ran the code and shown you that the output that we have gotten is different. So how do I do that? In order to do that, I'll have to make sure that context switch somehow happens after this line. So there are multiple ways to get that done. So some people, they write a for loop that runs for so many times, so that when the thread is in process of running that for loop, maybe a context switch happens and the control goes to another thread. Another way is that you can make the current thread sleep for certain duration. And there is a very easy way to do that. So you can use a method specified in thread class, and that is thread.sleep. This sleep takes in an argument which will be in milliseconds. So let's say I want to perform a sleep of 200 milliseconds. So guys, what will happen when the thread 1 has read the old value? Next thing it will do is it will sleep. So when it sleeps, your scheduler will automatically schedule the next thread, and that next thread will also now read the same value of x that was read by the thread 1. And that way, race condition is guaranteed to happen. Okay, this sleep method throws an exception. So I'll have to do something about that. One way is that I add that exception here in the signature of this run method, but I cannot do so. Why? Because this run method has been inherited from this interface, and that interface in its signature of run does not throw an exception. So another way to deal with that is to put a try catch over here. So I'll surround it with a try catch. Okay. However, I know that for now no exceptions are going to be thrown. But still, because it is needed by the semantics of language, so I had to put that try catch over here. Now I'll go ahead and run this method. So you remember it quite clearly, right? That there were two threads in action. And what really happened here is that when thread 1 got scheduled, it read the value, went to sleep, then context switch happened. The other thread also read the same value. And because of that, the value 1 is coming out over here. Okay, so important takeaway for you from here should be, you should try to figure out your compound actions and make them thread safe. There is one more thing that I want to talk about compound action. Compound actions are majorly of following nature: check, then act. I believe you understand the meaning of this thing. Check, then act. So the piece of code that you are able to see here, this is check, then act. It checks the value and then acts on top of that value. But what if in between check and act, a context switch happens? During that time, whatever you checked might not be true any longer. So that is the real issue. Okay, cool. So now I'll just make some code change over here. So now all that I'll do is, instead of doing this thing, I'll simply invoke number dot increment. That's it. And I'll expect the things to work perfectly well. So I'll run it again. And of course, I can see for now that the value is 2. It's totally right. In order to check it more rigorously, you can probably increment for so many times. So let's say you have a loop that loops over for 1,000,000 times and then invokes this thing. Now, we remember that there are 2 threads in action, right? So when both the threads have terminated, the value of x that I wish to see should be 2,000,000, and that is exactly what we are getting to see. You can run it over and over again and you'll be happy to see the same result. Why? Because the compound action has been guarded by the lock. Okay. Cool. It looks so good so far. But before I end, I'll introduce one more extremely important thing. It's very important to know. Guys, in the current code flow, what is happening? So let's say it was your thread 1 that got scheduled and thread 1 made a call to increment. Now, when it made a call to increment, what really happened? We entered inside a synchronized block. And then we invoked a method called as getOfX, which also has a synchronized block. So what is happening is that the same thread is getting inside multiple synchronized blocks in a nested manner. Do you realize it? Now, is it allowed? Of course it is allowed. That is the reason we are getting to see the right output. But what is this behavior? This behavior is of re-entering the same synchronized block again and again. In fact, not the same synchronized block, is of re-entering the code protected by the same lock again and again. Because we know that when we put synchronized here, then we basically acquire lock on the instance of this number. Here also, when we make a call to this, we acquire a lock on the same instance of the number. So is it allowed for the same thread to enter synchronized blocks in this manner? The answer is yes. And because of that, these synchronized blocks are reentrant by nature. So why I have introduced this term right now is because in the time to come, you will hear this thing again and again. You will hear about certain locks. So see, right now this synchronized keyword is a way to lock which is provided to us by Java. But at times we might want to build our own custom locks also. So sometimes you might not want to build a reentrant lock like this. But at times you might want to bring in a reentrant lock like that. So what is reentrant lock? Very simple idea. If there is a thread which has currently acquired lock on a certain object, then it can reacquire that again in the same process before releasing the previous thing. Okay, and it can happen in nested manner. So if you think how it would internally be managed by your system, then it would be something like this. Let's say a particular thread got inside your synchronized block for the first time. So your system would record that, hey, this is thread T1 and it got inside the synchronized block. So let's increment a counter by 1 unit. Okay. Now, if it gets inside synchronized block again, then it would again increment the counter. If it goes again, then again the counter will be incremented. So if let's say there were 3 nested synchronized blocks, the counter would finally be 3. And the moment it starts to leave the synchronized block, it would simply decrement the counter by 1 unit. Okay. So finally you would see that when we got inside 2 synchronized blocks and when we left all of them, the counter is again back to 0. This is the time when some other thread will be allowed to get inside the synchronized block. Okay, so keep it in your mind. Whenever a thread is inside a synchronized block, the same thread can again get inside another synchronized block, but other threads can't. Other threads can get only when the counter is 0, which means no thread is currently having access to the synchronized block. And you can think the same thing in terms of lock also, because synchronized block is a form of lock only. So when we acquire lock on something, in this case, then we can reacquire it before releasing it if it's the same thread, but other threads just can't. So this is an important property. This is called as reentrancy.